Okay, time for a new lesson. I hope this doesn't sadden you too much, but we are moving on from trig, at least for a while, maybe for good, I'm not sure. But we're going to start a new unit of instruction, and the topic is going to be systems of equations. So we're kind of going back to algebra for a little while. Now I'm going to start with what I got from an Algebra 2 system here, and it's solving two equations in two variables, and then we're going to move on to three equations in three variables, which is a lot tougher, and then in the future we'll move on from there into kind of the more theoretical stuff we're going to be learning. But this is just review stuff you're kind of supposed to know already, and then a practice assignment to make sure you're kind of brushed up on it. Okay, so a system of equations is when you have two equations or more at a time, and then two variables or more at a time. You know, from basic algebra, if you have like one variable, then you can solve for it, meaning you can solve the equation. So here I could subtract 2, divide by 5, get my answer. But if I have two variables, you can isolate one variable, but you can't truly solve it. If I isolate x, that does not give me a value. All it gives me is an equation with a y on the other side. Vice versa, if you isolate y, it just moves x to the other side, but it's not really a solution. You've just isolated a variable. So when there's two variables in two equations, the solution is going to be a pair of numbers. X will be one answer, y will be another answer. Or very often this is written as a coordinate pair, x comma y, which you're very familiar with. So if I want to solve this system here, I'm going to use there's different methods. I'm going to use something called elimination, and that's what we're going to be focusing on. I want to eliminate the x variables, and the way to do that is to make it so that this 2 becomes a negative 12. And the rule is you can multiply or divide if you want by any number, and as long as you do it to the whole equation, both sides of the equal sign. And then you are allowed to add equations together. So this equation right here, I'm going to sneeze. Hold on. Oh, just like old times being in the classroom. Sorry about that. I'm going to multiply this equation by negative 6, the whole thing. So it's like a big distributive property. So I get negative 12x plus 36y equals positive 6 times 6 is 36, carry the 3, 96. Then I bring down this other equation. I'm not changing it in any way at all. Draw a line and just combine these equations together. The negative 12x plus 12x cancels. 36y plus negative 8y is 28y. Over here, 96 minus 12 is 84. Divide both sides by 28. I believe 84 divided by 28 is 3, but you know what? Yep, 3. So my y answer is 3. Now to find my x answer, I go back to either one of the two original equations. Here, I'll go back to this equation and then plug that 3 in for y. So 2x minus 6 times 3 equals negative 16. Solve that. That's going to be minus 18. Add 18 over. 2x equals 2. Divide by 2. X equals 1. There's my x answer, or 1 comma 3 is the answer as a coordinate pair. So this is something you really should remember from Algebra 2, possibly even Algebra 1. This is a very common skill. It gets taught and practiced often in algebra. Now I'm going to scroll down and just make sure I did it right. Yeah, there we go, right there. So this is the general process that we're talking about. When you do two equations with two variables, it's considered to be about as easy as it can possibly be. Let's look at number 4 here. Let's say, again, I want to cancel out the x's. So I need those two numbers to cancel each other out or eliminate. So I want to turn this negative 3 into a positive 9. If I can make that a positive 9, then negative 9 plus 9 equals 0. So I need to multiply this whole thing by negative 3. 9x plus 6y equals 12. Yeah, 12. Yep. And bring down the other equation, negative 9x minus 6y equals negative 12. Draw a line, and when we add these together, yeah, those cancel out just like they're supposed to, but also 6 minus 6 cancels, leaving us with 0 on the left, and 12 minus 12 cancels, leaving us with 0 on the right. So we did not solve for a variable. Tried to, but we don't have x equals this or y equals that. This is a special case. So if you have no variable left after one of these steps, and you end up with what we have here, which is essentially a true statement, that means all real numbers are solutions. You can plug any x, y into this equation, and the same x, y will also work in that equation. So that's one of the special situations. Let me go down to number 4 in the answer key, and there you see infinite solutions. And if you glance at the answer key, you see there's no solution, infinite solutions. That comes up. Oh, you know what? I guess I made a mistake. It's not all real numbers. Every pair of numbers doesn't solve this, but there are an infinite number of solutions. So I kind of dropped the ball on that one. All real numbers is the wrong way to say it. So there's my sad looking infinity sign. You can write it another way if you want. That's okay. So there's number 4. So 2 and 4, let's look at number 6. Okay, so what do I want to eliminate? Again, well, let's say I want to eliminate the y's. If I could get a negative 4 right there, that would do the trick, wouldn't it? So I needed to multiply this whole equation, oops, it's supposed to be the eraser, by negative 4. So that's negative 8x minus 4y equals 24. If I bring down the other equation, and then eliminate here, those eliminate. Negative 8 plus 8. Negative 4 plus 4, that eliminates. So that gives me a 0. So now the variable's gone. Just like in the last problem, I know that this is going to be special. You're not going to get x equals this, y equals that, because the x and the y are both gone. Over here on the right side, 24 minus 27 is negative 3. So we know it's special, but it's not special in the same way the last one was. This was a true statement. 0 does equal 0. Well, here 0 does not equal negative 3. That's a false statement. When that happens, that means there is no solution. So, tried to make it as quick as I could, threw a sneeze in there as a bonus, but elimination method in a regular context where you get a regular answer, 1, 3, one that works out to be infinite solutions, one that works out to be no solution. So hopefully this is something you remember and it's something you can do. Oh, I guess I should check number 6. I kind of already did before we started, but yeah, there it is. No solution. All right, number 8 is quite different. When you get 3 variables with 3 equations, not to sound dramatic or anything, but it gets exponentially more difficult. There's a whole new system we have to do here. So the way that I have always taught it with fairly good results is you number the equations 1, 2, and 3. I didn't do that up here because you're not going to lose yourself. There's not, a whole lot of detail. There's just 2 equations. But here we have 3 equations. We need to choose a variable to eliminate, and we have to eliminate it twice. Once from one pair of equations, and then again from a second pair of equations. So it's kind of whittling it down in a sense. If you look at equation 2 and 3, the r terms are already set to eliminate. So I'm going to start by taking equation 2 and equation 3. I don't need to multiply anything by anything. They are just good to go. So I'm going to copy them down. I know some students who don't bother copying down every step, but it gets really hard to keep track of things. If I'm trying to give halfway decent notes, I'm going to write every step down. Okay, so I copied down equation 2 and 3, and clearly those cancel. Combine the rest. Positive 4s minus 3s is just 1s. I don't want those to look like 5s. Those are s's. 6t plus 2t is plus 8t. Negative 20 plus negative 27 is negative 47. Now, this is a whole new equation. S plus 8t equals negative 47. It is the 4th equation in the problem because we started with 3, so I'm going to call this equation 4. And I strongly recommend you do the same thing. Okay, now I need to eliminate r again, but I can't use 2 and 3 again, otherwise I just duplicate the work and nothing will come of it. So now I need to either use 1 and 2 or 1 and 3, but I can't use 2 and 3 again. I'm going to use 1 and 2, because I'm pretty sure I can eliminate the r here just by multiplying the first equation by -3. So here's what I'm going to do. I'm going to be combining equations 1 and 2. I'm not going to change 2 at all, so I'll just copy that down. I'll try to exaggerate my s's. Again, those are not 5s. Okay, equation 1, in order to cancel out with -6r, I need this 2 to turn into a 6. Well, how can you turn a 2 into a 6? You multiply it by 3. So off as a little side note, I'm just going to write times 3. So I'm telling myself here that I need to multiply this whole thing by 3. I get 6r minus 3s minus 9t. And what's 3 times 13? 39, right? Equals 39. Let me double check my work. So if I multiply this by 3, by 3, by 3, by 3, 6, -3, -9, 39. Okay. So now combine these two equations together. The 6r minus 6r cancels. -3s plus 4s, that's just 1s. -9t plus 6t, -3t. And, oh, what happened there? That was supposed to be a 20. I think I accidentally erased that 2 at some point. 39 and -20 is 19. And since that is the fifth equation on the page, I'm going to call that equation 5. Okay, we're not close to done. But, look, there's only one of these problems for notes and one for homework and a whole page to work it out. Okay, so we eliminated r once. We eliminated r a second time. Now we need to take the results here, equation 4 and 5, put them together and eliminate another variable. So I see that we have s here and s here. If one of them was a negative s, they would cancel. So what I'm going to do is I'm going to keep equation 4 the way it is. S plus 8t equals -47. Number 5, equation number 5, I'm going to multiply that by -1. So a little side note there, multiply everything here by -1. That's -s plus 3t equals -19. -1 times here, -1 times there, -1 times there. Yeah. Draw a line and do this elimination process one more time. S minus s cancels. 8t plus 3t is 11t. -47, hold on. -47 and -19 is -66. 9 and 7 is 16. Carry the 1, 4, 5, and 6. And here, now, you could say, okay, we got a sixth equation, this equation 6. But now, no, you don't have to do that. If you divide both sides by 11 at this point, you can solve for t, and we've got part of our solution done. 3 variables in 3 equations means our answer is going to be an ordered triplet. There's going to be an r, a s, and a t value, and we just figured out that the t value is -6. Although I'm going to try to write that a little more clear. -6. And honestly, I don't like those little variables down there. Just know that when you write your 3 numbers, they go in alphabetical order. So RST is alphabetical order. T then is going to go here in the last spot. Okay, so we're 1/3 of the way done. That might seem depressing because of all that work we did. But to be honest, solving it from here is not that much more work. So we found t. What you want to do is back substitute this one step backwards. And you can go into either one of these 2 equations, 4 or 5. Since I drew the arrow to 5, I'm going to use that. S minus 3t, but instead of t, now that's a -6, equals 19. So I substituted the -6 for t right there. So s plus 18 equals 19, right? -3 times -6 is 18. Subtract the 18 over. You get s equals 1. There's a second answer. S equals 1 is the second, or part of our ordered triplet, as it's called. Now all we have to do is solve for r. To solve for r, we need to back substitute to the previous step from where we just substituted just now. So we go up to one of the original three equations, either 1, 2, or 3. I'm going to choose equation 1 for no particular reason. I think it just looks a little easier. So if I take equation 1 here, 2r minus s, but s is 1, minus 3t, but t is negative 6, equals 13. So I plugged negative 6 in here, and I plugged a 1 right there. R, of course, is the variable that we're trying to solve for to finish the problem. So 2r minus 1 plus 18 equals 13. 2r plus 17 equals 13. Right? Negative 1 plus 18 is 17. Subtract 17 over. 2r equals 13 minus 17 is negative 4. And then divide by negative 2, or I'm sorry, divide by 2, you get an answer, which is negative 2. That is the third part of our ordered triple, negative 2. And let me check, negative 2, 1, negative 6, negative 2, 1, negative 6, right there. So this is the process for solving 3 equations in 3 variables. A lot of work, that's why there's so much room that I gave you here, and only one of them. But I am going to ask you to do your best on number 7. Try to follow the general same flow that I showed you over here in number 8, and see if you can get it done. If it's a huge struggle, you can maybe try to Google other resources or get on YouTube and find other videos that maybe go through this another way. Maybe just rewatching me do it. Maybe that'll help. I don't know. Of course, you can text or email with questions, or use the comments for questions, or email me. Otherwise, give this a shot. The first 3 should be fairly simple, just to kind of refresh your memory from Algebra 2. Number 7, a bit more of a challenge. And just so you know, as far as making this into a pre-calculus topic, we take harder problems like this and find other ways to solve them, which in theory become easier and easier, but more complicated math as you go. So, all right, I'm going to stop right there, because I'm just babbling anyway.